Hello, welcome back to Algebra 1. We're on lesson 3.6, so it's going to be unit 3, or if you're following along online in the online book, it is module 2B, page 6, but it's our third unit and our sixth page of the lesson. So it's 3.6 when we look at what lesson we're on. Now, we've gone over linear system of equations and how to solve them by graphing, how to solve them through substitution or elimination. We've also looked at linear system of equations using real world models. So now we're going to go one step further and we're going to look at linear systems of inequalities and how to solve those. So we have here a system of linear inequalities. And the main thing that you have to do with the system of inequalities is we're going to solve it just like before. We're going to graph our system of inequalities. And because they're inequalities, remember when we graph inequalities, we have to shade in the region of the inequality. Also remember, if you have greater than or less than, you're going to have a dashed line or dotted line. I think it's called sometimes a broken line. If you have a greater than or less than or greater than or equal to, you're going to have a solid line. So you need to remember that when you're graphing inequalities as well. Now, we have two inequalities here. The easiest way to graph these is to go ahead and solve for the y variable. So we want to get y by itself. So let's take the first one. 2x minus 3y is less than or equal to 12. And remember, when we're solving for inequalities, if we multiply or divide by a negative, we need to flip the sign, flip the inequality, right? So going back over here, we're not going to start by multiplying or dividing. We're going to start by just moving some stuff around. We have right here this 2x, and we're going to want to move it over to the other side. So we've got negative 3y that's going to stay on this side. And then we've got our 2x. It's moving from the left side to the right side. So we're going to put negative 2x. And then we've got our 12. It's positive. It stayed on that side. So we're going to just keep it positive right there. Now, in order to get this y by itself, we have to undo what's being done to the y. So what's being done to the y is being multiplied by a negative 3. So now we're going to either multiply or divide. But are we doing it with a negative? Yes, we are. So let's go ahead and flip that sign so we don't forget. So we're going to divide by a negative 3 on both sides. And this y divided by when we divide by negative 3 becomes just y, because the negative 3 will disappear. Now, when we divide negative 2 by negative 3, two negatives will become a positive, and I can't really do 2 divided by 3, so it's just going to stay a fraction there, 2/3. And then I've got a positive 12 here, divided by a negative 3 will become a negative 4. So that is my first equation that I have. And my second equation, x plus 5y is less than or equal to 20. So I'm going to have 5y is less than or equal to minus x plus 20, because I just took this x that was on the left and I moved it to the right. And when it switches sides, it has to switch signs. So it went from positive to negative. Now I'm going to divide. This is back to multiplying or dividing, but I'm dividing this time by a positive. So I'm going to keep my sign going, my inequality symbol going the same direction. And a 5y divided by 5 is just y. And what is our coefficient for this x right here? Well, it is an implied number 1. So it's a negative 1. So divide that by 5 and you're going to get negative 1/5. And then there's your x, plus 20 divided by 5 is 4. So we have our two equations here and here. And so what we're going to do is we're going to go ahead and graph these equations. Let's graph the first equation. Here you have, for whatever reason, I did not put in the equal sign when I graphed this. I just did greater than. This is supposed to be, since we have greater than or equal to, we're supposed to have a solid line here. I tried to use graphing, I used Desmos in this case to graph this so you wouldn't have to put up with my wobbly lines, but it looks like you're going to anyways. So we have a solid line and we've graphed on this side of the inequality. Okay. Now we need to graph the second inequality, and where these two graphs overlap, not just meet at one point, but where they completely overlap is where our answer to the graph will be. So let's see what it is when we graph the second line. So here we've graphed a second line, and it should also be a solid line because it says it is less than or equal to. So I'm trying to draw in a solid line for us right there. And then it is this side that we graphed. Now, if you notice, this area right here is where the graphs overlap, in between this part of the line and this part of the line. So this is where our answer is. We're not going to write it in numerical form. We just want the visual of the graph. So we have solved the system of linear inequalities by being able to graph these equations. Not equations, inequalities. All right, so I've got another one for you. I want you to go ahead and pause the video and try this one on your own. Go ahead and try to solve this through graphing. Pause the video. All right, welcome back. We're going to go ahead and solve these. The easiest way to graph these is to get them equal to y. So I have 2x minus y is greater than -3. So that's going to end up being negative y is greater than negative 2x minus 3. My 2x over here on the left, switch sides to the right. It was on the left a positive, so on the right it's going to be a negative. My -3 stayed on the same side, so it stayed a -3. Now I have negative y here. That means that I have a -1 implied in front of it. So in order to undo the negative here, I'm just going to divide by the negative. And remember, that means I need to flip the sign. So y is going to be less than positive 2x, because if I divide this side by -1, I have to divide all of my terms by -1. So positive 2x and positive 3 now. Those are my two new terms. Now my second one here, 4x plus y is less than 5. We want to get y by itself, so we're going to have y is less than -4x. That's supposed to be an x there. 4x plus 5. So my 4x was positive over here on the left. So when I moved it to the right side of the inequality, it became a negative. So y is less than -4x plus 5. So now we can move on to graphing these inequalities. All right, here is the first inequality. This is 2x minus, I'm sorry, y is less than 2x plus 3. If you notice, we cross the y-axis. Our b is 3. So we cross the y-axis right there at 3. Our slope is a positive 2 over 1. Okay, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And you see it is a dashed line. That is correct because we have just less than here, not less than or equal to. And it is y is less than this. So what's less than on the y scale is what's going to be colored in. So this is our graph for that first equation. Let's look at the graph of the second equation here. All right, we have got y is less than negative 4x plus 5. So we know it's going to cross the y-axis at the positive 5 right here because our b equals 5 and our m is going to be negative 4 over 1. So if we start here at 5 and we go down 4, 1, 2, 3, 4, and over 1, you can see right there's another one. Go 1, 2, 3, 4, and over 1. You can easily see how to graph this on your own paper. Now it is a less than symbol, so we do have the dashed sign right here. Also, we know that y is less than, so the lower part of y is going to be what is graphed. Now, where these two shaded regions overlap, right here, this is what the solution to our system of linear inequalities is going to be. Go ahead and pause the video. Try this one on your own as well. All right, so we've got x minus y is less than or equal to negative 2. X minus y is less than or equal to negative 2. We want to get y by itself. Negative y is less than or equal to. My x is going to switch from the left to the right. So it's going to switch from positive to negative, negative x. My negative 2 is staying on the same side. Negative x minus 2. Now I want to undo this negative in front of the y, so I need to make sure to switch my sign. It's going to be a positive y. And if I undo this negative symbol, then I need to switch the signs on every term. So it's going to be a positive x and a plus 2. So that is my first equation. We can actually go ahead and look at that graphed. And we have a positive 2 is our b. So our positive 2 is right here. That's our b. B equals positive 2. And then m in this case is 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, etc. And you can see that this is supposed to be greater than or equal to. So I am supposed to have a solid line here, not a dashed line, a solid line. Then we have that y is greater than, so the higher as the y climbs in numbers, that's what's going to be shaded up there. All right, so now let's look at the second equation here. X minus y is greater than or equal to 2. So we're going to have minus y is greater than or equal to. My x is going to change sides from the left to the right. So it switches from positive to negative x. My 2 stayed on that side, so it's going to be a positive 2. I still have a negative here in front of the y. So if I want to undo that negative in front of the y, I need to switch my sign. That's the first thing I need to do, switch my sign. And if I undo the sign, the negative in front of the y, I need to switch my signs for every single term. So my x, instead of being negative, is now positive, and my 2, instead of being positive, is now negative. So my b for this equation is negative 2, and my m is 1 over 1. So let's look at how this would graph. Here we go. This is almost complete. We see that it's less than or equal to, so we do need to have a solid line for this one as well. Now, both of these are solid lines. We see that they're graphed correctly. This is at negative 2, and we go up 1 over 1, up 1 over 1, up 1 over 1. So these are definitely graphed correctly. And I've got 2 shaded regions, one right here and one right here, but there's no overlap. So what does that mean? Well, remember, we can actually have multiple types of answers with inequalities, just like we can with systems of equations. So systems of inequalities can have different kinds of answers. So the answer for this one is no solution. If the graphs do not overlap, you have no solution. Okay. So now let's look at, sometimes you're going to be given a graph and asked if a point fit, is a possible solution to that system. So what we need to do is we're going to look at this graph and see where that point fits. If it's inside the shaded region, then we can say, yes, it's a solution to the system. If it's not in the shaded region, then we say, no, it is not. So this point is 25, -5. Remember, this is the X or the horizontal value. -5 is the Y or the vertical value. All right, so let's look at the X value first, 25. These are in, if you notice, each line here is by the count of 5. So this is 0, 5, 10, 15, 20, 25. We know it's going to be this way horizontally. Now we need to look at vertically. We want -5. That means we're going to go down. So -5, that point is right here. Now, it's unfortunate that the graph that they provided us gets cut off right at that point, but we can tell, we can assume from this graph that it's going to continue because of the arrows here and here. And so they don't intersect to cut it off until further down. So we can say for sure that yes, this is a solution to this system. All right, I've got 2 more for you. I want you to go ahead and try these on your own. Pause the video and give it a shot. Welcome back. So the first one is the given point of solution to the system, 2, 3. Let's figure out where this point is. It's going to be to the right 2 and 1, 2, 3, up 3. Well, that's not really in the shaded region. It's on the line. But is that line included in the system? Well, considering that it's a dashed line, our answer is no. If it were a solid line, our answer would be yes. So let's look at this next one. Is a given point a solution to the system? 2, 6. So we want to go, oh, these marks are counted by 2. So it's 0, 2, 4, 6. Same with the vertical, 0, 2, 4, 6. You can see that by the 4 and the 2 here. So we want to go over 2 and up 6. That's going to be this point right here. Again, it's not in the shaded region. So we have to look at the line itself. In this case, the line is solid. And so our answer is yes, it is a solution to the system. All right. System of linear equations. Basically, we're presented with the exact same question as before. Is 2, 1 a solution to the system? But instead of being given a graph, we're being given the inequalities. So how do we solve this? Well, we're going to solve it the same way we would before when we had a system of equations and we were given a point. We're just going to plug it in and see if we get some true statements. If we get 2, if every statement that we plug this solution into is true, then the answer is yes, it's a solution. If anything on it, if we plug in this as a solution and any of these statements are false, then we have not a solution. It is not a solution. The answer is no. Okay, so let's go ahead and plug these in. I'm going to have 2 times 2, because this is the X, remember, and this is the Y. So anytime I see an X, I'm going to plug in the 2. 2 times 2 minus 3 times what the Y value is, which is 1 in this case, is less than or equal to 12. Now we're going to plug this into our calculator, okay? I'm going to do 2, open parentheses, 2, close parentheses, minus 3, open parentheses, 1, close parentheses. And I'm going to hit enter, okay? And what I get in this case is going to be 1. So 1 is less than or equal to 12. Is this a true statement or is it a false statement? Well, 1 is not equal to 12, but 1 is less than 12. So far, so good. This is a true statement. So let's do the same thing with the next one. We've got, it just starts off with X. So I'm going to start off with just 2 plus 5 times Y, which is 1, is less than or equal to 20. So I'm going to plug this into my calculator. 2 plus 5, open parentheses, 1, close parentheses, enter. And I get 7. 7 is less than or equal to 20. Is this a true statement? Well, 7 is not equal to 20, but it is less than 20. So this is definitely a true statement. So my answer to my question is yes. 0.21 is a solution to this system we were given. All right. we've gone over how to find the solution. We've gone over to how to verify if a solution is accurate or not. Now, the last step we have in this chapter is to go over real world models of linear systems of inequalities. So we have a word problem here. And what we need to do is we need to write some equations, and then we're going to figure out how to solve it. So it actually doesn't ask us a question here. For whatever reason, the book that we have just gives us the information and doesn't actually ask a question, but we are supposed to write a system of linear inequalities, and I want us to go ahead and graph it to find the solution, because I want to look at something specific about this. Miss Jones wants to buy at least 10 books. Okay, well, we know she wants to buy at least 10 books. That means she wants to buy more than or equal to 10 books. However many books she buys, she wants them to be more than, greater than, or equal to 10. So 10 or more. Each paperback book costs an average of $10, and each hardcover book, so we know she's buying paperbacks and hardbacks. But I don't want to use P and H, because if I'm going to be graphing, I need to know which one's going to be my vertical change and which one's going to be my horizontal change. So I'm going to say that paperback is X and hardcover is going to be my Y. So X plus Y is going to be greater than or equal to 10. All right, so that's my first equation. Since we're solving a system of linear equations, it should be obvious that I need to find at least one more equation in all these words. So let's keep looking. It says that the paperback book costs an average of $10. Okay, paperback I put as X. So 10 times X is going to be how much I can spend on a paperback. And it says that hard books cost an average of $20. So 20 times Y. And Miss Joan wants to spend less than $240 on the book. So less than $240 on her books. So if we add these two costs together, the cost of the paperback and the cost of the hardback, we want it to be less than $240. All right, so we have two systems of equations here. And in order to graph it, the easiest way to graph it by hand is to solve for Y. Okay, so our first system of equation, let's say X plus Y is greater than or equal to 10, is going to end up being Y is greater than or equal to 10 minus X. And in this case, we can see that B is the constant, right? So B is 10 and M is the coefficient of X. So it's -1 over 1. So you don't always have to have it in standard format order, not standard, I'm sorry, slope intercept format, where the variable term comes first. As long as you have it equal to Y and then simplified, you should still be able to identify that the constant is B and the coefficient of the variable is the slope. Okay. All right. So let's look at the second one here. We've got 10x plus 20y is less than 240. I want to solve for y, so I'm going to leave that. 20y is less than 240 minus 10x. Okay, now in order to get y by itself, I have to divide by 20. Since it's a positive, my symbol is going to stay, my inequality symbol is going to stay the same direction. So 240 divided by 20 is going to be 12. And then 10 divided by 20 is going to be -1/2 X. So I can see that B is going to be 12 and M is going to be -1/2. All right, so let's look at the graphs of these inequalities. So here we have the graphs, and again, for whatever reason, when I created these, it did not put in any solid lines. So I know that this first one here is going to be a solid line. Y is greater than or equal to 10 minus X. This is B is 10, and my slope is -1 over 1. So that's my slope. So this is the one that needs to be the solid line here. Oh, This is why I do it in Desmos, so you don't have to suffer through these lines. I'm so sorry. Okay. So we know that y is greater than, so this is the side that's shaded for that one. This second equation, y is less than, we know that our y-intercept is 12 right here, and we know that we are going down 1 and over 2, down 1 and over 2, down 1 and over 2, and that is a dashed line, so that is correct there. And it says that y is less than, so the lower part is going to be what is shaded here. Now, we see an overlap, but what I want to look at with this is there are actually more constraints on this than is being indicated by our two equations, because you cannot purchase any kind of negative number of hardbacks or the paperbacks. So you cannot have any negative X or negative Y as answers. So we're going to actually cut off right here, our shaded region, and we're going to cut off right here, our shaded region. So the only thing that is actually a solution here in our real world example is going to be this shaded region as well as this solid line right here and right here, because she can purchase 0 books and she can purchase 0 books here. Remember, X is our paperback, so she could purchase 0 paperbacks and she could purchase 0 hardbacks, but she does not want to spend $240. She wants to spend less than, so that one's a dash line. So you can see a little bit more accurately what our actual solution is. So sometimes you may have to, with real world equations, adjust your graph a little bit based on some constraints that are implied and not implicit. All right, the drama club is selling tickets to a play. An adult ticket costs $15 and a student ticket costs $11. The auditorium seats 300. What? So I know I can't exceed oops, that's supposed to be a student. Actually, let's say this. The adult tickets we will call X. The student tickets we will call Y, because we are going to be graphing these again. So X plus Y, can that be equal to 300? It can. Can it be greater than 300? It cannot. It has to be less than 300, because if there's only 300 seats and you sell 500 tickets, you're going to have a riot on your hands. Some people are going to be pretty upset. So you want to have X plus Y be less than or equal to 300. Now, it says that they want to make at least this much money, 3630. So does that mean that they can make exactly that much money? Yes, it does. So we're going to put that little equal sign there. Does that mean they want to make less than or more than that much? Well, they want to make more than that much money. So we're going to have greater than or equal to. Now we need to think about, what is this equation going to be over here? Well, we know it has something to do with how many tickets they sell. How many student tickets and how many adult tickets. And this is the money. So in order to find out how much money they make, we have to take how much the cost of a ticket is times the number of tickets. Well, an adult ticket costs $15. Adult is X. So to find the amount that you make, you do 15, which is the cost of the ticket, times X, the amount of the tickets. A student ticket costs $11. So you're going to do $11 times Y, the number of tickets, to find out how much that costs. Add those two things together, and that needs to be greater than or equal to 3,630. Okay, you're going to go ahead and solve for Y. And when you do that, you'll be able to graph your equation, which we have right here. Now, again, we can constrain this even further than we have on our graph showing here, because you cannot show a negative amount of tickets. It looks like these lines are actually solid. So we can sell anywhere in this shaded region or on either of the lines. So anywhere in this triangle is a possible solution to our graph or our system of inequalities. All right, well, that concludes the lesson for systems of linear inequalities. If you have any questions, go back, rewatch the video, make sure you take good notes, make sure you write down all of your examples and show all of your work. So when you're going back and studying for your exam, which is coming up soon, you'll be able to have all the information you need. And we'll see you in the test review next.